In this video, I'm going to show you how to create this explosion effect from scratch. First, let's create a new project. We can call it Niagara Tutorial and use the third person preset. I click on create. Once you have opened your project, we will download texture from Niagara Example from Epic Games. To do so, go to Fab, type Niagara Example Pack, select this one and add it to your library. After that, go to your Epic Game Launcher, go to Unreal Engine, Library tabs, and search for Niagara Example Pack. Update if needed, and add to your project. For my case, Niagara Tutorial. When it's done, you should see a Niagara example folder in your content browser. This one. Now let's create a new folder, Niagara Tutorials. And inside, create two folders, one materials and one VFX. Now we will create a basic material and a basic Niagara system and implement them step by step to see the result in real time. So let's create a new material, colleagues, m_explosion, and open it. For the blend mode, search alpha composite. Now we will add a texture sample parameters UV so we can assign our texture in the material instance. Let's rename it emissive opacity. And the second one, it will be parameter sub UV, and this one it will be the normal. Why? Because we will use two texture that we can find in the Niagara example folder. Example, texture, sprite, and we will use this one and the normal one. We are using a Flipbook texture. It's a grid of 64 frames 8x8 that Niagara will play one after another to create the motion of the explosion. In our case, multiple types of information are stored in the texture. We have emissive in the red channel, occlusion in the green, and opacity in the alpha. We are going to extract this information and organize it using reboot nodes. So back to our materials. So we're going to extract the red channel, but before storage with a reboot node, we will use a saturate function to make sure all the value provided is between 0 and 1. So we only will use the red for the emission and the alpha for the opacity. Now we can store this value using reboot node. This one, and we'll call it emission. And this one, it will be opacity. And same for the normal texture. Normal. You can comment that and it will be our texture data. Now we are going to put all this information into our material. To do that, we will check use material attributes and link all the information inside. So we will start with get materials attributes, and we will feed that to set material attributes. Here in the material attributes, we will add a base color, this one, and for base color, we will create a vector parameters base color. It will be basically our base color if you want to color or smoke, for example. And we put that in base color. Could make a default value of white. Okay, now for the opacity, same set material attributes. In the material attribute, Now we're going to set opacity, and for opacity we are going to use this opacity reroute that we created before. So right click and type opacity, and we have name reroute opacity, and we put here. And same for maybe we make emission before. So same set materials, we put it this to this, and before we make emission, emissive color, and we put our emission reroutes inside, and for the end the normal reroutes. So same set materials attributes, add normal, and search normal. Where is it? Name reroutes normal. Okay, at the end you can connect to your material attributes. So our structure is done. Obviously we need to add a lot of more stuff, but we will do it after. Just before create an instance, we just add a group for our parameters. So this one, it will be 01 texture. Same for this one. And for these parameters, you can set to 02 base color. And we will make some group for each parameters that we create. You can save. So now you can create an instance of these materials. mi underscore explosion. Open it. You can dock it. And as you can see, we have parameter groups. And now we can select our texture that we download before. So you can enable emissive opacity, normal, and base color. For base color, it would be full white with full opacity. And for the texture, open your content browser, go to Niagara Example, Texture, Sprites. And for emission opacity, we will use the EOO loop, this one. And for the normal, this one. Now we can create our Niagara system. So Niagara tutorial VFX, new Niagara system, create empty Niagara system, and call it n underscore explosion. Open it. So reduce this. I prefer full black for the preview. So go to preview settings, environment, and select black. We will see better our effect. So now let's go to our emitter, add minimal emitter, go back to detail here. In emitter update, we will use spawn burst because it's an explosion. We will start with maybe 5 particles just to see it. In particle spawn, we'll use shape location. Yeah, the sphere. Maybe a little one. Or maybe something bigger, like 50. Okay, let's add some velocity. So our particle will move. Fix issue. And for this velocity mode from point, because we want our particle move in all direction. Okay, maybe something bigger, like that. Maybe 500, but we'll add some drag, so it's slow it down with time. Maybe like that. Okay. Maybe make some bigger particle. Besides, for name uniform. After that we will go to random uniform, but now okay, we can start with that, and we start to add our material. So go to sprite render, and here open your content browser, go to Niagara tutorial materials, and add your material instance. Okay, now go to sub UV, and because it's our texture, it's a grid of 8 by 8, we need to type 8 by 8 here. So that we have only one image per frame in our square. Also, we are going to enable sub UV blending. This option creates a smooth transition between our animation frame. Instead of jumping from one frame to the next, it blends them together, making the explosion look much more fluid and professional. As you can see, our animation doesn't play. It's because we need to add some sub UV animation. Click on sprite render, and now you can see our animation play. But we're going to start to add some stuff, our material, and first we remove this big square. So let's go back to our materials. So why we have this big square? It's because we add some base color, but this base color is on all our frame independently of the opacity. So we need to tell add this base color only where the opacity is not 0. So to do that, at the end, make some space, we use a get material attribute, and we will select our base color and opacity, and we will set material attributes. We will set to base color, and what we do is just multiply. So we multiply opacity by base color, and when the opacity is 0, we don't see a color. So connect this to base color and to the end. You can save, and now if you go back to your emitter, you can see the animation playing, but we didn't have our big square anymore. Okay, so before we move forward, let's make some quick adjustments on our Niagara system. Maybe add more velocity, something like that, but with a bigger drag. So a particle, yeah, maybe something like that. Okay, and maybe more particle for now. Maybe 10 particle. Okay, I think that's a better start. So now we have our smoke. Let's create our fire. For our fire, we will modify the structure of the emissive color. We will use a black body node for the color. Indeed, I will put a link in the description. But what does black body node? Basically, it will simulate the effect of a black body radiation. And what's black body radiation? It will give you a color based on a temperature. So it will simulate a better understanding of what flame should look like. So with this node, we will feed it with temperature. So let's create scalar node, scalar parameters, and it will be our hot temperature, and another one, scalar. It will be our low temperature. As you can see, we need to put a value between maybe 7,000 for the hot temperature, and maybe 1000, but this value can be modified later. But we need to choose a value between this value. So we need to add a lerp node, lerp linear interpolates. And what these nodes will do, basically, again, I will put a link in the description, but if you type linear interpolate, so the linear interpolate expressor blends between two input value based on the third input. So it will blend between the hot temperature and the low temperature based on another value. And we will feed the black body with this value. For the alpha of our lerp, we will use our emissive texture. Alt and click to remove line. But before connecting it, we will add a power node. Power. This allows us to tweak the contrast of the emission since our texture values are between 0 and 1. Using a power value lower than 1 will push the gray area to our right, increasing the emission coverage without going above 1. So let's take a value of 0.3, for example, and feed the lerp with it. And now we can connect all of this to our emissive color. And let's make some quick adjustments. Let's create a new group, for example 0.2 emissive. Same for low temperature. And inverse this because we want, when value is close to 1, we want to have our hot temperature. So you can save. And now if you go to our Niagara system, we can see we're starting to have fire. But now we have some red square, and we have this square because when our emission send low value, should still put a color. So low color, a red color. So to remove that, we will use a smooth step node. And again, I will put a link in the description. So this node will interpolate between 0 and 1 for value between a min and max threshold. So again, we will feed smooth step with power. For the min 0, but for the max, we will divide our lower value by our hot value, and we multiply our black body by this value. And why we do that? It's when we have a lower value, we want that multiply our black body color by a value close to 0 when it's a low value emission. And this way it will remove all the square red around our explosion. Now if I save and I go back to, as you can see, we remove all this square. But as you can see, we don't have smoke anymore. We only have fire. So we need something to start with fire after a few seconds, depending on the life of the particle, of smoke. So go back to our material and we will add dynamic parameters from particle. So we will use a parameter from particles that we will animate with some curve and use these parameters with our emissive texture. So we name the first parameter, for example, like particle temperature scale. And reroute this to particle temperature scale. And now we will use these parameters just after this power. So let's use multiply. So by our particle temperature scale, and now use it for the value and the alpha. So with this particle temperature scale that we will modify in our Niagara system, we will create the smoke. So now save these materials and go back to our Niagara system. In particle updates, let's add dynamic material parameters. And as you can see, for the first one, we have particle temperature scale at 0. And if I have 1, I have my fire. So now, if I animate it with float from curve, let's start with this curve. We will see, start with fire, and after time, we have smoke. So we can play a bit with this curve, maybe lower more faster. And now our materials start to look like okay. So let's now implement our Niagara system. So for the spawn burst, let's make some random range, maybe between 2 and 3. And we will add also a spawn rate and make float from curve. Select both key, right click and click on user. Okay, and for the scale curve, maybe a value around 60. For the curve index, let's choose loop age. And for this value, we want maybe 0.25. Click on F to focus. Yeah. Why we do that? Because we want at 0.25 seconds, we don't anymore create a new particle independently of the age of diameter. In initialize particle, let's continue to random everything. For the lifetime, random range float between 3 and 7. Same for the spot size, random uniform between maybe 400 and 550. And for the rotation, direct angle and randomize between minus 45 and plus 45 degree. Let's put our emitter in real world to see what it looks like. It starts to look good, but we need to make some improvements. Let's go back. Let's add some scale split size. So the simulation would start almost equal to 0. Not this one. This one. And reach his full size at the mid-age. For the shape of the curve, right click on the first key, select user and weight tangents and put curve something like that. And we can see now it starts small and become bigger. Same for the color. Let's add some scale color. And we want that at the end, even the smoke disappear. So we'll use float from curve for the alpha. So float from curve. Maybe add some key. Right click, user. Same for this one. And you can play with this value to have something that you like. Maybe 0.31. Let's also randomize the temperature. So in particle spawn, type new, set new or existing parameters. We will add a new command float. It will be our F2 temperature. And make a random range float between 0, 0.5 and 1. And in particle update, add same new. And in parameters, let's find our temperature, yeah, this one, and add it. And same as before, float from curve, right click, add key, add 0.5 and maybe something higher, maybe 0.8. And we will use this temperature in our dynamic material parameters. Instead of this curve, let's click on reset and put our temperature parameters in it. And now we will add some more variety on our color. You maybe notice it, but our explosion is supposed to fade to black at the end because we use scale color on the alpha, and maybe reduce it, but there is no effect on our explosion. Is because we need to use this information, the alpha of the particle, in our material. So let's go back to our materials and use this information. Next to our dynamic parameters, right click, particle color, and we want to use the alpha of the particle, and we use again reboot node and call it particle alpha, and we will combine it with our opacity. So let's make some bit space to make like that. Call your particle alpha, and we will use again a power node, but we can't use directly the power mode, because our alpha starts from 1 to 0. And if we apply a power node to our opacity with a value lower than 1, it will boost the opacity value, making the overall effect look much thicker. For example, if I multiply 0.2 power 0.1, it will increase the value. That we want is the opposite. We want to reduce our opacity. So before use a power node, we use 1 minus node. Basically, it will take the opacity 1 minus the opacity. And now we are kind of the opposite of our opacity. And now we can use particle alpha for the power. And just after that, we will use 1 minus to have our real value of opacity. And again, we can use saturate node to make sure our value is between 0 and 1. And go to opacity. We can save. And now the opacity of our explosion decreases over time. And also to bring back our smoke, I made some little mistake. When we set the temperature particle parameters in updates, we don't want to set it with a curve. We want to multiply our previous value by a curve. So let's modify it, make multiply float, and we want to use our temperature. And this value of temperature that is already between 0.5 and 1, multiply it by float from curve, and you can use same point as before, maybe. And now, sorry, at the beginning we have a fire, and by time, smoke appear. Alright. Something else we need to fix is his sharp edges when the effects touch something. So go back to our material. To correct that, we will use a DepthFade node and we'll place it after normal. So let's add get material attribute because we need to use emissive and opacity. At the end, again, we will set materials attribute and we will set emissive and opacity, and we place it by this node, and we will call our nodes depth fade. So we put the opacity in it, and for the fade distance we will use a particle radius. So if we change the radius of our particle, the depth fade will still work. And put it in opacity. We can save and see the result. As you can see, it works for the smoke, but for the emissive, we still have these sharp edges. So we will multiply the output of this node by emissive. So multiply emissive by the output and plug it into emissive color. Save again. And now our emissive color and our smoke are fade, and we don't have these sharp edges anymore. But because we lose a bit of our brightness, we can multiply our output, the emissive color, by just a value to increase, multiply by a value, for example 3, to increase the brightness of our emissive color. And now we have something brighter like before. And to add a bit of realism, we want that our smoke and our explosion in general just move a bit upward. So let's add some linear forces. And we want to multiply this vector by a float. And the float will be our temperature. And for the value we want to push in the z axis, maybe a value of 1000. So when the temperature is kind of high, the simulation will go up fast, and at the end when the temperature is low, the explosion stop to move higher. And we can also add a bit of wine. So let's add some wine force to have some movement in the y and x axis. So let's push to 1 and 1 for the x and y axis, and again randomize. So random range float between 25 and 50. As you can see, your explosion move just a little bit in y and x axis plus linear force in the z axis. Congratulations, you just made an explosion effect from scratch. In this tutorial, we reproduce the main emitter of the explosion for Niagara Pack, this one. If you enjoy this video and want me to break down the other emitter, please like this video and let me know in the comments. Also, if you have any issue or question, I'll do my best to answer them. And thanks for watching.